Here we've got the integral of something, this product where this something differentiates to a multiple of this. So we try substitution. Here's the something then, x squared plus 10. So du dx is equal to, label this as I, 2x. So du over 2 then will equal the x dx, which we can replace. So we've got u cubed times x dx, which is du over 2, which is u to the 4 over 8 over 4, and there's a 2 there already, so it makes 8. So that's equal to u to the 4 at the end over 8 plus k. The u was x squared plus 10. Oops. Next one. This one, here's the something, and here's the product, and the something differentiates to a multiple, or it differentiates to this 3x squared. So we try u equals 1 plus x cubed. Du dx is equal to 3x squared. So du is equal to the 3x squared dx, isn't it? Which we can replace. So I equals then u squared is that part. This part can be replaced simply by du. So we end up with u cubed over 3. Now what values? 0, x is 0, u is 1, and x is 1. 1 plus 1 cubed is still 1, so that's 1 plus 1 is 2. So we end up with then, top, take bottom, put 2 in, 2 cubed, which is 8 over 3, minus 1 cubed is 1 over 3. 8 thirds minus 1 third is 7 thirds. Okay, next one then. Here, it's better to write this as one, bring it up the top and write it as a product. So that's what you would write down to start with when you wrote the question, hopefully. So we get that. And now, you see the something differentiates the two lots of that in the product. So that's what we try. So du dx then is 2x. So the x dx, so du over 2 is equal to x dx, isn't it? So, what have we got? It's the integral. This integral is actually between 0 and 1 in the question, so let's put it in. So it's u to the minus a half. X dx is just du over 2. Raise the power by 1, divide by that number, which is a half. 2 times a half is 1. So that's what we've got then. And then we want to integrate that between the values. So what have we got? When x is 0, u is 1. And when x is 1, u is 2. So we've got top value 2 to the half, or root 2 minus 1 to the half, which is root 2 minus 1. Next one then. See this something? It's 1 over something, and it differentiates to 5 lots of this. So you think of it as a product in terms of this. That's how you think of it in your mind's eye. So that is a product, and this is 1 over something. So x to the 5 plus 2 then, du dx. Try this substitution is 5x to the 4. So du over 5 then is equal to x to the 4 dx. So we can put it in. So I equals, it will be 1 over u. X to the 4 dx is du over 5. So you could put the fifth here even if you want, or 1 over 5u. Same difference. Integrate that then, it will be a fifth ln u. And that was an indefinite integral, so that's just equal to 1/5 ln of u, which is x to the 5 plus 2, plus a constant of integration. Just squeeze it in there. Okay, next one. Let's have a look at this one. Okay, good. So, see the 1 over something? C to the x times 1 over something, isn't it? And that differentiates to the other part of the product. So u is equal to 1 plus e to the x. Du dx is equal to e to the x. So du is equal to e to the x dx. So 1 over the u then, that's that part there. E to the x dx is just du. So this works out at log of u. So that's the log of 1 plus e to the x, plus a constant of integration. Next one. Now this, we can move this up to be minus a half. So I'm going to write that as integral between 0 and 1 of x times 3x squared plus 1 to the minus a half dx. So that's what we've got then. That's our problems written in a user-friendly form. So, u here, see the 3x squared plus 1 differentiates to 6 lots of x in this product. So that's what we try. Du dx is 6x. We want x dx, don't we? So du over 6 equals the x dx. Now we've got x dx, we've got this u to the minus a half, and the x dx is du over 6. So raise the power by 1, divide by a half, 6 halves are 3, and then we've got a definite integral. When x is 0, u is 1, and when x is 1, 3 1 squared, so 3 plus 1 is 4, u is 4. So we end up with then, top value take bottom, 4 to the half is 2, so it's 2/3, minus 1 to the half is 1, so that's 1/3, so it's 1/3. Okay, last three. Let's have a look at this next one now. Here, cos of something, and cos of something, the something differentiates to 2 lots of the other part of the product. So 2 plus x squared then in here. So du dx, to make the substitution, is 2x. So du over 2 then is equal to x dx. So I equals the cos of u, isn't it? And the x dx is du over 2. Integral cos is sine over 2 plus k, so that's equal to a half sine of u plus k. This one now then, what you think of this, although it looks like that, you think of this as, that's what it is. So you can see the product and that something differentiates to cos, doesn't it? So let's try that. So du cos x dx, cos x dx is that. So I equals bu to the 6, cos x dx is just du, which is u to the 7 over 7 plus k, which is equal to sine x to the power 7, which we can write like that, over 7 plus k. Next one. Here we've got cos to the power 4, so u would be cos x, wouldn't it? And cos differentiates to minus 1 lot of sine, so it's a multiple of this part of the product. So that looks good. Du dx is equal to minus sine x. So du, put the minus over here, is equal to sine x dx. So I is equal to then Sine x dx and cos to the 4, so that's u to the 4. And sine x dx is minus du. So put the minus tag there. Minus u to the 5 over 5. That's a 5. Okay, so when x is pi over 2, cos pi over 2, cos 90 is 0. And when x is 0, cos 0 is 1, isn't it? So that's equal to 0 to the 5 is 0 over 5, which is 0, minus, that's a minus, minus 1 to the 5 is 1 over 5. So we end up with 1/5.